Good morning, sir, madam over there. I am Jahnavi and I am from RGPT RK Valley and my teammates are M. Gautami, P. Vishnuswati from RGPT RK Valley. We have done an internship with energy technologies on IoT and our topic is home automation. Let us discuss about what we have learned during the internship. Basics of C programming, introduction to IoT, embedded systems, our project home automation and what are the project requirements and then project demo conclusion. We are learned during the internship the topics of C programming, introduction to embedded systems, introduction to IoT, Arduino IDE and Picsimlab, introduction to ADC, CLCD, LDR and concepts of PWM, introduction to temperature sensor system, serial tank and Blink IoT app. Coming to the basics of C programming, we have learned many things in C programming like introduction to C, conditionals, loops and operators, arrays and pointers, functions and strings, storage classes, some basic concepts in C++. Coming to the introduction to C, we have learned many things in C programming like applications. C program is used in embedded software development and OS kernel development, etc. C is a general purpose language and it is free formatted language. Coming to the keywords of C, there are 32 keywords which have their own categories. For example, char, int, float, double, signed, unsigned, while, go to, break, if else, and so on. We can represent data in binary, octal, decimal, hexadecimal, bit, byte, and word also. Basic types of C is integral, floating point, modifiers, and qualifiers. Modifiers are used to change from 8-bit to 4-bit and 4-bit to 2-bit, etc. Qualifiers are constant and volatile. Next, conditionals. There are single iteration, multi iteration, and unconditional like if and its family, and so on. In single iterations, we have switch case, and multi iteration means for loop, while loop, do while loop, etc. And coming to the operators of C, these are the symbols that instruct the compiler to perform specific arithmetic or logical operations on operands. We have basic types of operators. Arithmetic means plus, minus, into, division, etc. Logical operations are and, are, not, etc. Relational operators are less than, greater than or equal to, less than or equal to. And assignment operators are double equal to, not equal to, etc. Coming to the arrays, array is a collection of same data type and addresses are sequential in arrays. Syntax for array are first you have to write data type and size and then syntax. This is the syntax of arrays. Coming to the pointers, it is used to store address. The pointers acts as an integer but it doesn't have same size. In case if it is a null, then we call it as a null pointer. There are two rules. Rule 1 is whatever is there in int, it takes same for the counter. Rule 2 is the differencing and referencing concept. We can represent pointer as star ptr. Next, coming to the functions, it is a set of instructions written separately whenever the certain operations to be performed. First thing we need to observe here is function is declaration protocol and signature, then function definition and then function call. Syntax for function is first we have to write return type, function name, input arguments and function definition. In function definitions, we have to write specific int x, int y like that. Next, coming to the strings. Strings are the set of things tied or written together on a thin code and easily stores ASCII and its extensions. These are the sequence of characters. And then storage classes. Storage classes are auto, register, static, local, extern, etc. Here we are having some memory segments. Those are text segments, stack, read segment, and heap. And we have learned some basic concepts in C++. Those are constructors, destructors, structures, hooks, concepts, etc. Next, what is IoT? IoT is IoT means Internet of Things. It refers to the rapidly growing network of connected objects that are able to collect and exchange data in real time using embedded sensors. For example, thermostats, cars, lights, refrigerators, and more appliances can be all be connected to the IoT. The goal behind the IoT is to have devices that self-report in real time, improving efficiency and bringing important information to the surface more quickly than a system depending on human interference. Smartphones play a key role in the IoT because you can control many IoT devices through an app on a smartphone. Next, what are the benefits of IoT? It improves the customer's experience and saves time and money, enhances employee productivity, helps people to live and work smarter, and enhance employee productivity, integrate and adapt business models, make better business decisions, and generate more revenue. Next, coming to the inflection points of IoT. First thing is hardware is getting very cheap. Means compared to previous years, nowadays hardware is getting cheap for designing the projects. Next, mission to mission solutions are mainstream. Two devices can talk to each other. Next, connectivity is proliferating. Means we can connect multiple devices. Connectivity is increasing drastically. Next, software is more advanced. Means there are many built-in libraries to write code easily. No need to worry about writing the code. Next, cloud cost, scale, flexibility. By connecting the smartphone to uh, by connecting to smartphone, it increases flexibility in works. Next, Internet of Things. Unique objects connected to the internet means multiple devices are connected to each other. Next, devices, not people. Here we can't communicate with people, we will connect to the devices. Bidirectional communication means we can easily connect two hardware components like AirDrops to laptop by turning on the Bluetooth. Next, large complex data flows. When we talk about IoT, there are large number of devices that are getting connected to the internet and complex data will flow. Next, new types of insight means new type of understanding. We can control lights sitting at the office. Next, coming to the requirements of IoT, many devices means we can connect many devices that are connected to the internet. Next, large scale. Large scale means the scale is increasing means software get more advanced day by day. Coming to the security requirements, security is very important when it comes to the IoT. If we take example of home automation, in this we are controlling each and everything in the home through the IoT. Suppose we are sleeping at night, someone is going to turn on the TV in our home. It is not possible to hack in IoT and no one should be able to get our data. If we use cheap quality hardware components, then they may be able to hack our system. So we have to maintain proper security. Next, coming to the volumes of data. Volumes of data means there is large number of data that is flowing. Then we have to take care of large volumes of data. Next, coming to the end-to-end integration, the data flows from one end to another end with integrity. Integrity means the data should be remain same. There should be not any noise. If there is no end-to-end integration, then there may be miscommunication occurred between transmitter and then receiver. Next, coming to the challenges of IoT, first thing is addressing. Addressing means when devices are communicating with each other, they are having some own address. For one or 100 devices, it is easy to give addresses, but for large number of devices, it is not easy to give their own address. This addressing is difficult because each device must have unique address. Coming to the scale, scaling may vary every day. One day we can use less number of devices, another day we can use large number of devices like that. Scaling is nothing but either increasing or decreasing the volumes of data. Next thing is connectivity. When we connect large number of devices, these large number of devices can keep pushing the data, then there will internet traffic occur and there may be possibility of losing the data, means large data trafficking can occur. Next thing is data volume. Data volume is how to transfer the data. That means flow of the data. When we get large number of data, then it may be tough to store the whole data. Next, device size. Device size means we cannot fit all the hardware in a single board. We are having solutions for these challenges also. Solution for the addressing is by using hub or submodules we can overcome addressing challenge. It is same as YouTube, means if there are so many videos in the YouTube, but we have to subscribe for one channel, then it is easy to get their videos only. Here, by using pub or submodules, devices can be subscribed to particular data. So we can easily overcome this addressing challenge. Next, scale is overcome by using or purchasing cloud storage. We can overcome the challenge of scale. Next, we can overcome connectivity traffic by using queues. Means we have to keep storing data into queues one by one. Next, data volume. It is also overcome by using cloud storage. Next, device size. Devices using IoT protocols AMQP, MQTT. Using these protocols, we can build small size IoT devices. This will help us to solve this issue of device size. Next, coming to the introduction to embedded systems. Embedded systems is a combination of any hardware and software which is intended to do a specific task. An embedded system is a microprocessor based computer hardware system with software that is designed to perform a dedicated function either as an independent system or as a part of a large system. At the core is an integrated circuit designed to carry out computation for real-time applications or operations. When classifying embedded systems based on performance and functional requirements, embedded systems are divided into four categories. Those are real-time embedded systems, standalone embedded systems, network or networked embedded systems, mobile embedded systems. These are the categories of embedded systems. Now we can discuss one by one. What is meant by standalone? Standalone is for standalone we have two perspectives. First perspective is it is just like a slave. It will follow the commands blindly. Example of slave is semi-automatic washing machine. Once we write a program to washing machine, it will run at any time by using that commands. Second perspective of standalone is taking decision on its own. It doesn't require any human interference. Example, Tesla cars or self-driving cars. If there is traffic, it will change the route by own. If there is any construction of road, then it will change the route. Next, coming to the real time. Real time, it will complete the task within a given amount of time. Means we are setting certain time. In that time, task will be completed. The time may be in nanoseconds, microseconds, minutes, etc. But not immediately. For example, airbag system of the cars. Next, coming to the network, when more than one device gets connected, it is called as the network. It may be Bluetooth, Wi-Fi, Internet, router, etc. The connection may be wired or wireless. Next, coming to the mobile. Mobile means anything that is mobile or portable. Example, smartwatches, headphones. Next, hybrid. It is nothing but more than one category. Means example smartwatch, mobile and internet. Next, components of embedded systems. There are various components of the embedded systems. So we have microcontroller. What is meant by microcontroller? Means a microcontroller is a single chip VLSI unit, also called as microcomputer, which although having limited computational capabilities passes enhanced input or output capability and a number of an on-chip functional units. The components present in microcontroller CPU, input-output devices, RAM, ROM, timers. These are connected separately. Next, microprocessor. A microprocessor is a single VLSI chip having a CPU. In addition, it may also have other units such as floating point processing, arithmetic unit, and pipelining units that helps in faster processing of instructions. Here all devices are connected to each other. Input, output, RAM, ROM, CPU, timers. Next is system on chip. Here we are having microprocessor, microcontroller, memories, etc. Next to memories means we are having in memories RAM, ROM, hybrid memories. Again, RAM is categorized to three types. OTP means one time programmable, EPROM, micro ROM, EEPROM, and then masked ROM. Next types of RAM are SRAM and DRAM. SRAM have less power compared to the DRAM. Why? Because static current to retain the data. Next, coming to the hybrid memory. Hybrid means example of hybrid memory is our phone gallery. Next, sensors. Output of sensor is analog or digital. Here we are using ADC and DAC converters to ADC converter is used to convert analog signals to digital signals and DAC converter is used to convert digital signal to analog signals. Next, actuators, diagnostic port, FPGA and ASIC. FPGA, ASIC are the additional ICs. Next slide will be continued by my friend M. Gautam.
Good morning, everyone. I am M. Gautami from Educator Archivali. Let us discuss IoT-based home automation. Home automation refers to the automatic and electronic control of household features, activity, and appliances. In simple terms, it means you can easily control the utilities and features of the home via the internet to make life more convenient and secure, and even spend less on household bills. There are some features available in home automation: remote lighting control, appliance control, home automation security systems and cameras, alarm systems, real-time text and email alerts, digital personal assistant, integration, keyless entry, voice activated control. These are the features of home automation. Next, in this project, we are going to control the garden lights of the house and also controlling the temperature of the house and water level of the tank in the house. Next, requirements of the project. There are some requirements of the project. There are Picsimlab, Arduino IDE, LinkCap, Arduino Uno, LDR sensor, LEDs, CLCD, temperature system, Ethernet shield, serial tank. Coming to the Picsimlab. Picsimlab means Programmable IC Simulator Laboratory, a real-time emulator of development boards with integrated MPL, MPLog, MPLabs, X, AVR, GDB debugger. It supports microcontrollers, Picsimlab, SimAVR, GPSim, and different simulators. Picsimlab have integration with MPL, ABX, Arduino IDE for programming the board microcontrollers. As the purpose of Picsimlab is As the purpose of Picsimlab is to emulate real hardware. It does not have any source of built-in support. It supports several devices that can connect it to the board of simulation. There are LEDs, push buttons, EMERTXE, LDR, CLCD, temperature sensor, etc. There are different boards in Simlab like Arduino Uno, GP board, Bluefield, etc. But we prefer Arduino Uno. Arduino IDE. The open source Arduino software IDE makes it easy to write code and upload it to the board. This software can be used with Arduino board. Arduino IDE is open source software designed by Arduino CC and mainly used for writing and compiling the uploading the code. Here we are writing the code and we are uploading the code into the Picsimlab for the simulation. Coming to the null emulator. Null emulator is a software that enables on the computer system Come next, Blink app. Blink is a IoT platform for iOS and Android smartphones that is used to control Arduino, Raspberry Pi and Node MCU via internet. This application is used to create a graphical interface or human machine interface by compiling and providing the appropriate address on the available widget. With Blink app, anyone can connect their hardware to the cloud and build a no-code iOS, Android and web applications and to analyze real-time and historical data coming from the devices. Control Arduino Uno. Arduino Uno is a microcontroller board based on the Atmega 328. It has 14 digital pins and 6 analog inputs, and operating voltage of the Arduino is 5 volts and input voltage recommended 7 to 12 volts, and flash memory is 32 KB and EEPROM is 1 KB. Clock speed is 16 MHz. Coming to the next component, that is LDR. LDR, it is a sensor light dependent resistor. It is a light sensitive device most often used to indicate the presence or absence of the light or measure the light intensity. It has a variable resistance that can change with light intensity that falls upon it. Whenever more light is falling on the component, that means LDR, the means less resistance and more voltage. Whenever less light is falling on the LDR, that means more resistance and less voltage. Based on this LDR, we are going to control the lights that should be on or off. LEDs. LEDs is a light emitting diode, is a semiconductor light source that emits light when current flows through it. LED having two terminals, one is positive and negative. When we connect positive terminal of LED and positive terminal of the supply voltage, then then LED will be on. Whenever we connect positive terminal of the LED and negative terminal of this supply voltage, then LED going to off. Next, CLCD. It is a liquid crystal display. CLCD having 16 pins. It is having 16 columns and 2 rows. LCD is a type of flat panel display which uses liquid crystals in its primary form of operation. It is having 16 pins and its VSS is connected to ground and VDD is connected to 5 volts. V0 is connected to the potentiometer positive, and enable is when you want to display anything, we are going to enable the enable pin. Next, D0 to D7 are the data pins, and LCD have a large and varying set of use cases, consumers business as they can commonly found in the smartphone, television, computer monitor and instrument panels. Next, temperature system. Temperature system. This temperature system having LM35 temperature sensor and it is used to sense the temperature and one cooler and one heater. Whenever temperature is low, we are going to on the heater. If temperature is greater than 35, a cooler going to work and cools the surroundings. Next, Ethernet shield. The Arduino Ethernet shield allows the Arduino board to connect the internet using the Ethernet library and to read and write an SD card using the SD library. Next, serial tank. The serial remote tank is tank simulator controlled by a serial communication protocol. The tank has several sensors and actuators that can be read and controlled using the communication protocol. We are assuming this serial tank as a water tank and we are going to control the water flow. Next, scope of the project. The home automation should be simulated on Picsimlab Simulator. Blink IoT mobile application used to control the devices should be able to control the lights and temperature of the home, inflow and outflow of the water tank in the water in the water tank. Functional requirements of the project. Garden lights control. Control the LEDs during the day and night. Temperature control system. To control the heater and cooler remotely according to the temperature. Water tank inlet and outlet flow. To control and monitor the water levels of the tank remotely. Next, coming to the block diagram, we are having three requirements. One is garden lights control. Whenever brightness is less in surroundings, we are going to on the garden lights. Whenever brightness is high in the surroundings, we are going to off the garden lights. Here LED sensor value. Here our microcontroller going to read the LED sensor value based on the reading from the LDR. Vary the brightness of the LED, which resemble the controlling the garden lights based on the availability of sunlight. Next, block diagram. Temperature control system. The temperature control system consists of a heating resistor, an LM35 temperature sensor and a cooler which resemble the temperature control system at a home. Read the temperature from the temperature sensor LM35 and display it on the CLCD. Control the temperature system using the on-off in the Blink IoT app. We are going to display the temperature on Blink IoT app and temperature in CLCD. Whenever cooler button is high in the Blink app, we are going to turn on the cooler. If the button is low, we are going to turn off the cooler. Whenever heater button is high in the Blink app, we are going to on the heater, otherwise we will off. Temperature threshold temperature control. If the temperature is more than 35, we are going to turn off the heater and send the notification to Blink IoT app and display on the same CLCD. Next, water tank inlet and outlet valve control. Read the value from the water in the tank through the serial communication and display on the CLCD. Control the volume of the water in the water tank by controlling the inlet and outlet valve. By sending the commands through the serial communication, display the volume of water in the CLCD. We are going to display the volume of the water tank in the tank and display the volume of the water in the gauge widget. Display the water on the CLCD. Inlet valve control is the button widget in the logic high. Turn on the inlet valve by sending the commands to the serial communication. If the button widget is at logic low, turn off the inlet valve by sending the commands to the serial communication. Outlet valve control. If the button widget is logic high, turn on the outlet valve by sending the commands to the serial communication. If the button widget is logic high, turn off the outlet valve by sending the commands to the serial communication. We are going to control the volume of the water tank. If the volume of the water tank is less than 200 liters, 2000 liters, turn on the inlet valve and send the notification to Blink mobile app and display the same in the CLCD. Next, slides can be explained by our friend Swati.
My name is Vishnu Swati. Now let us see the project demo and the simulation. This is the Arduino IDE code which we are going to use in the home automation project. Here in the main.h file, we are defining the virtual pins which we are going to use in the Blink app. This is the temperature system file which we are defining our functions to control the heater and read the temperature values of the temperature sensor. This is the serial tank which we are going to use to indicate the water level in the tank to enable and disable the inlet and outlet flows. Here this is the LDR file which we are going to control the brightness of the garden lights. In the main file we are using the blink light function which by this we can read the values of the virtual pin from the Blink IoT app. This function will write the temperature values to the virtual pins. Now let us check the simulation. Now let us see about the simulation. Here in the Picsimlab, we have to load the hex file which we are verified in the Arduino IDE, and it is a binary file. Now we are loading this file. You can see it is already loaded, and in the serial tank the water starts to going the fill, and I can present you the mobile screen. Now in the mobile screen it is showing the volume is 2140, and now we can see the inlet flow is off. Now when we on the inlet, the tank is start going to fill now, and in the LCD it is showing the inflow is on. When it is full, it is the inlet flow is automatically off, and we can on the onlet here, and the volume is starting gradually decreasing, and that notification you can also see in the LCD. And also here you can see the when the volume is full, it is showing that the inlet we have to off the inlet, and when it is less than 2000, it is showing that inlet is on. Here we can see the both inlet and outlet is on. So now we have to off the outlet now, and it start going to fill, and the volume is full. Now when the volume is again full, it is going to off the inlet, and you can see the notification. Now let us see about the LDR sensor. When we switch this is the parameter we are going to use, and when it is the night time, the lights are going to on, and when we are down this parameter, it is the daytime, and the LDR will be off. This is working as the garden lights of our home.
Now let us see about the temperature system. When the cooler is on, it is showing in the LCD that the cooler is on and the fan is start rotating. And when we off the cooler, in LDR it will show the cooler is off. When the heater is on, the temperature going to increase, and we can see in the mobile screen the temperature is showing in the gauge meter. And when it is greater than 35, it will send a notification that the temperature is greater than 35 and heater is off. Now the temperature starts decreasing slowly, and this is about the temperature system. So we have seen the simulation how it works in the serial tank and in the Picsimlab. Now we are going to view the conclusion of this project. Using the Blink IoT application and Picsimlab simulator, simulated home automation where LED and the temperature system serial tank resembles the light heater, cooler, and the water tank in real time. CLCD acts like a dashboard used for displaying the events. Widgets from Blink IoT app like the button widgets are used to control the heater, cooler, and inlet valve, outlet valve. Gauge widgets to display the temperature and the volume of the water. And this is about our internship. And thank you, Emergy. We are exposed to the new technology. Providing this 5-week internship in IoT. We have learned a lot through this internship, and we are exposed to the new technology. Thank you.